Many people in Ontario and across Canada are trying to make a difference in how they live. Here at the Nolalu Eco Centre, just outside of Thunder Bay, Ontario, a couple has made a straw bale house just to make that difference.
Hi there, I'm Hubert and Drag, and this here is Jacqueline, my partner. And we both designed and built the Nolalu Eco Centre. It's Northern Ontario's largest straw bale building that's powered by sun and wind. This is a straw bale house, and traditionally straw bale homes have what's called a truth window. It shows you there's actually straw in the walls. In this case we have an old frame, and you can see the straw sitting there. It insulates incredibly well. It's a local resource, and it's a waste product that stays on the land after the farmer is done. We can just pick it up here from the local farmer. And it sits in the walls, R48 insulation value.
This house looks fairly typical to most other homes. Is it constructed in the same fashion as traditional homes?
It's built as a post and beam house, so the weight of most of the house is sitting on the post and beams, and the straw bales are used as infill. Once it's in place and all the cracks have been filled with loose straw, it gets plastered twice, and then the house is done. That part took us about 6 to 8 weeks.
It's fairly easy if you know what you're doing. First you have to learn a little bit how to work with the straw, but if we can do it, I think everybody can build a house like this.
You just have to be determined and know what you're doing. And the nice thing about building with straw is that it's very flexible. You can shape it in all kinds of designs, and we like to shape it in nice curves, so you don't have hard angles and the light seems to be fanning inside the house. Straw is easy to work with. It's hard work, but it's easy to build walls with and to shape them in all kinds of nice forms and arcs and curves.
What advantage does this straw bale house have over other homes?
Well, the big advantages of straw bale building is it's super insulated. The walls have approximately an R48 to R50 insulation value. That's twice the building code, more than twice the building code. So it's easy to keep cool in the summers that are getting hotter and hotter. It's easy to keep warm in the winter. Up here in Northern Ontario, the winters are routinely -30, -40, so it's easy to keep the house warm. You don't need to burn a lot of firewood. Go ahead.
It is also good for the environment. Straw is a natural product and it's a waste product.
Our house has a combination of high-tech and low-tech ideas. This is a low-tech idea. Sun shines in the winter and hits this wall. Up here is just drywall. But under here, where the sun hits, it's 4 inches of concrete. It warms up, it retains the heat. It's a heat-retaining wall. And after the sun sets and it cools off, the heat in this place gets released and keeps the house nice and warm. It's called thermal mass heat-retaining wall.
Could you give an example of the kinds of energy savings you get from a home like this?
It's mostly heating and cooling. The summers can be pretty hot, short but hot. We never even have to cool the house. The house cools itself, so no air conditioning required. Heating the house is relatively easy. We burn firewood in our kitchen stove. Most homes this size use approximately 2 to 3 times the amount of firewood we use. A lot less cutting and splitting, which is nice if you get older. And of course, the solar panels and wind turbine provide us basically free power to the house. We're making more power than we need on days like today. And instead of using the power instead of burning it off as heat, we can feed it back into the grid for a credit. So instead of using power, we're making power, and we actually get paid for it. Now our house is heated by the sun. In the winter, the sun warms up the house, so we don't need a lot of backup heat. But when it's a dark day, we need to light a fire, so we use this wood-fired stove. It's a Mennonite design. It's been around for centuries, but it's a new one, and it heats the house on dark days when there's no sun warming up the house. It also has an oven, and it has a hot water reservoir, so we always have hot water. and a warming tray, and there's in the firebox there's a heat coil that warms up the bathroom over there where there's no sunshine. So it's 4 purposes into one built in. And in the summer, of course, we cook using propane, a normal propane gas stove. There's a lot more energy in the sun than there is in the wind. Today we also make some wind power. The wind turbine is spinning nicely, and we have to go out every day, a few times a day, to rotate the panels to track the sun. So we always get most of the sunshine on our panels. And it goes into the house and it feeds all our power requirements. And on a day like today, we're making much more power than we need, and that power gets fed back into the grid for a credit. So instead of using the grid to power our house powers the grid. We're a tiny little power plant, solar and wind power plant.
And the big question on most people's minds is how affordable is a house like this?
The bottom line, eh?
Mm-hmm.
Well, on average, a house like this is approximately 5, maybe 6% more expensive to build than a conventional home. The nice thing, of course, is the moment you move in, you start saving money. You don't have to cool it, you don't have to heat it as much, you don't have to power it. You're actually making money in selling back to the grid. So within a few years, the extra costs will have been paid for, and after that, it's almost free cruising.
What is the approximate payback time?
Payback time depends on what system you're looking at. For solar hot water, approximately 6 to 7 years. Wind and solar energy is longer. It depends on what you're paying for it, of course. Right now it's approximately 16 years, but every time the hydro prices go up, our payback time goes down. I expect it'll have paid for itself in 12 to 13 years.